Welcome back. So in this video, we're going to continue on with those functional groups, and here we're just going to get a bunch of practice on deciding what type of functional group that we have. So when I'm dealing with the types of questions where I'm spotting a functional group, I'm always asking this primary question: are there any heteroatoms? And if so, what type of heteroatom? And I like to ask in the order of halogen, and then nitrogen, sulfur, and last I check the oxygens. So if there aren't any heteroatoms, then we know we're dealing with the hydrocarbons. That's your alkenes, alkynes, and aromatics. Okay, and then we look to see if we have the halogen, nitrogen, sulfur, and oxygen in that order. Okay, so when we look at the first two examples here, notice how there are no heteroatoms in either one of these. Right, so we know we're dealing with hydrocarbons, and we want to spot any double or single bonds, any double or triple bonds. If it's a double bond, remember that's an alkene. And it may help as we're going through the examples to put dots where you see carbons. So remember, carbons are going to be at any kinks or at the end of a line that doesn't have a heteroatom attached. Okay, so here we have 6 carbons, and you'll notice that there is a double bond only up top between 2 carbons. So that can't be an aromatic because we don't have the alternating double and single bonds, like what you see here. Okay, so when we have just one double bond between the carbons, we know that that's going to be an alkene. And then in the second example, we do have the 6-membered ring and it's alternating double and single bonds, and so that's what we call aromatic. And technically the whole structure is aromatic, okay? But all I care is that you spot that one aromatic ring in the fused 3 rings. Okay. Now in the third example, notice how we do have heteroatoms, and we do typically want to go through, is it a halogen, nitrogen, sulfur, or oxygen? And we notice that it's an oxygen. Okay, so as soon as I see that I have an oxygen, my next question is, how many bonds are there with that oxygen? And are there any other oxygens attached to that carbon that has the oxygen? So what's important is that I locate the carbon that's attached to the oxygen, and I locate the 2 carbons on either side. And I say, okay, I only see one oxygen atom, and that one oxygen atom is single bonded to a carbon. And now that I notice that it's single bonded, that gets me down to 3 options. It's either a phenyl, an ether, or an alcohol. Now remember, for it to be a phenyl, I would have to have an aromatic ring, and I don't see that. An ether would mean that I would have to have a carbon attached on either side of that oxygen. So notice how there's a carbon attached on one side of the oxygen, but not on the other. So that means that it has to be an alcohol. Okay, because it can't be a phenyl, again, no aromatic ring, and it can't be an ether because there's not a carbon attached on the other side of that oxygen. It's a hydrogen. Now in the next example, again, I spot that there is a heteroatom, and again, it's another single bonded oxygen, and there's only one of them. Okay, but this time I also spot an aromatic ring. And I do have to make sure that the oxygen is directly attached into that aromatic ring, and it is. So that does make this a phenyl. Okay, now in the next example, again, a single bonded oxygen, and there's only one of them. And this time I notice that there is a carbon on each side of that oxygen. Okay, so remember, if I have a carbon on both sides, that's going to be my ether. It can't be a phenol because I don't have the alternating double and single bonds within the ring structure. And it can't be an alcohol because of the fact that there's carbons on both sides. Now in the next example, now I have 2 oxygens. Right, so I need to look at all the carbons that are attached on either side of those oxygens. Okay, so if I have both a single and a double bonded oxygen, then I know that I'm looking at either a carboxylic acid or an ester. And remember that a carboxylic acid has to be at the end of the chain. So what that means is that that single bonded oxygen would have to have a hydrogen coming off of it on the other side, but it doesn't. It has a carbon on both sides of that single bonded oxygen. And so that's what makes it an ester. Okay, next one, we only have 1 oxygen this time. And it is double bonded. So I know that it's either a aldehyde or a ketone. Remember, an aldehyde comes at the end of the chain, which means that the carbon that's part of the carboxyl group would have a hydrogen coming off of it. And it is assumed there is a hydrogen coming off of that, right? There's not a carbon on either side. So this is indeed an aldehyde. Okay, but in the next example, you'll see that that's double bonded as well. But this time, the carbon that's part of that carboxyl group has a carbon on both sides of it. So when that happens, that's when you have that ketone. Okay, last 3. Now remember, I'm always checking those heteroatoms in the order of halogens, sulfurs, nitrogens, and then last are the oxygens. So the fact that I see a nitrogen, that stops me right there and says, okay, if I have a nitrogen, I've got one of 2 options. It's either an amine or an amide. Remember, amines have just nitrogens with carbons surrounding it, and there's no carboxyl group attached to those carbons. But with an amide, it is when I have the nitrogen attached to a carbon that is part of a carboxyl group. And I do have that this time, so that is an amide. Okay, and then the next example, this is where I have both a single and a double bonded oxygen, all attached to the same carbon. And so it's either a carboxylic acid, and that's right here, it's either a carboxylic acid or an ester. Okay, remember that carboxylic acids come at the end of the chain, which means that the single bonded oxygen has a hydrogen attached to it. And it does indeed have that, so we're looking at a carboxyl group, or a carboxylic acid. Okay, and then the last one, we have a nitrogen, and remember that the carbon directly attached to the nitrogen, we're asking if it has a carboxyl group on it, if it has that double bonded oxygen, and it doesn't, so that means that it has to be an amine. Okay, so we'll go ahead and stop this video, and I'll do a third one, very short, where we just look through bigger molecules and we do all the functional groups located in that big molecule.